And then we say, well, okay, we're going to categorize it from after the Second World War to 2010, and then you see a big jump. Because if you look at this, right, if you compare Ghana and China, Ghana is at the bottom right there. China is somewhere here. You say, oh yeah, 1.1, 2.0, that's not much different, right? In terms of percentage change, 1.1, 2.0. But of course, if you take out mortgage, or if you borrow a computer or car loans, that makes a lot of difference, the percentage there. Okay, if you look at from 50 to 2010, look what happened. Well, Ghana actually goes down. Yeah, and look at China, it's 4.9. Big difference there. And then if you look at 1980 onward, so more recent year in the last, 20 years or so. This is now 20 some years. So you got China has jumped up from 4.9 to 7. Look at India, 2.9 to 4.4. So I especially highlight China and India because these two are considered, you heard about BRIC. How many of you heard about BRIC? If you buy some stock market, you want to make sure, at least 10 years ago, it's not so true now. I think there's a new one come out. So does everybody know what it stands for? B stands for Brazil, and R stands for Russia, and I stands for India, C stands for China. So these are the so-called emerging economies. If you want to do your paper on this is very relevant, yes. The emerging economy, and especially look at China and India. Look at the growth rate that they had in the last, more recent year. It's a big jump if you compare to the rest of the countries here. You got 2 point something, you got 0.9, look, 4.4, look, 7.0. So now the point that I want to make by showing you all these percentage changes, that small changes, the last point here, and the growth rates actually make a very big difference. Because let's look at some, okay, you saw others. So this basically from what we saw before, I added a few more countries. And, well, yeah, look at China and India. Ghana, not so much because it just kind of like stayed flat. But then look at India, what happened after 1990. China, same thing. After they entered the WTO, World Trade Organization, China started to grow very fast. And Brazil is one of the emerging economies. It's not quite like this industrialized economy, but still is doing quite well. Okay, let's look at some percentage. So let's say 1800, you deposited, you buried $10 under the tree stump, by the tree stump. You cannot bury it under the tree stump. So you dig a hole and bury it, $10. And what is it going to be like today? Nothing. Probably all shredded, eaten by mob or bugs or whatever. But if you put it in the bank, you would have earned 4% interest rate or interest payment. So in 2015, the account is actually worth 45,000 something. So how do you get that number? This is how you do it. You take the $10, which is your original amount, or what we call principal. How many of you have heard about that term? I'm sure you have, right? Anybody has taken any finance or accounting class? Okay, so that's your principal, $10. You start off with $10, and then you say, well, if it is 4%, so you raise it like that, 1.04, because 4% is 0.04. And you raise it to the powers of the X number of years that it has been. In this case, it's like from 1800 to 2015 is 215 years. So you raise it to the power of 215. Now, do not attempt to use your basic calculator to calculate this, because you never get it right. It will take forever to. Some of you have financial calculator, you got this exponential function, so you could use. If we ask you on the test, we will not give you 215, we'll give you the most 3. So you can manage with your basic calculator. So this is not possible. You have to do it 215 times. It's very likely, in fact, it's very, very likely that you make a mistake. So, okay, that's what you got. So the payment of interest not only on your original deposit, which is known as your principal, but also on previously accumulated interest. Wow, how about that? Have you thought about it? So that's a lot of money there. Now, so let's look at this. So the point that I'm trying to make is, it depends on the interest rate. If it is only 2%, look, this is how much you get. 215 years later, only like $706 compared to this 45,000. But what if it is 6%? Only 2% higher will kick you into something like, how do you read that one? 2.7 minutes. Wow, that's a huge difference. 1% difference. So every time you negotiate this thing with the bank, you know, to get your loans or whatever, oh boy, 1% interest difference is a lot. I just happened to talk to a banker 2 days ago. I'm supposed to get a lot of discount for interest rate. Then there was one part they didn't give it to me. I said, well, how about that one? And I said, oh yeah, you have to go back and reapply this thing, and it's been 2 months. So I said, forget it. Let's go ahead and move forward because, you know I could save a little bit, but never mind because I intend to pay it all off by the end of the year. So that doesn't mean anything like they can give you more percentage, 0.25% interest difference rate. Okay, here's the main point for doing all this math here. Where is the economics? A small sum compounded over a long period can increase in value. Hey, we all know that, but how much? What's the point you're trying to say? A small differences in interest have a very large impact on the value. So now we're applying that to economic growth, finally. So here it is. Here's the main point. If you get nothing so far, be sure you get this. Economic growth rates are similar to compound interest rates. Government policy that affect the long-term growth rate, long-term, by a small amount will have a major economic impact. So just like what you saw earlier, you know, you look at Ghana, it's like, oh, the growth rate was like, what, 0.9, 1.1, but if you look at China, it's like 7%. Wow. Some of you might say, oh yeah, I could do it in my finger. You know, 1% to 7% is only 6% difference. But that is a very huge difference too. So what we're talking about, anytime government has any policy, economic growth is going to have a very major economic impact. Years later, this is called laggard effect. Laggard. And all the economic growth is like that. I mean, you look at Great Recession of 2007, and why is that we're still saying, oh yeah, we're still feeling the effects of it? Because every time you have a recession, you don't get over it so fast, especially if it was a very long, protracted recession. It has taken years for you to feel the effects, and we should have got out of it already, but you know, look at the interest rate, is still so low. Should have been a lot higher. So let's come back to this very important equation, and for your test next time, this equation is very important. It's like, you know this equation, you know it all. The whole chapter is the same. Okay, let's go ahead and define this. I'm going to write it down here in equation variables format, and then I'm going to explain it. So your Y is your real GDP, your N is the number of employed workers. So remember, we have N plus unemployed workers is your labor force. So I'm going to give these three terms here. I'm going to label it A, B, and C, okay? Because we're going to talk about this quite a bit. Your P is your POP. Your POP is your total population. So basically, A has an English name to it. This is your so-called GDP per capita, IPL, because that purpose and because you're dividing by the whole population. Does anybody know what is the population of the United States right now? Give me a ballpark figure if you know.
360 million.
360 million? Okay, pretty close. Very good. Might be a little bit on the high. I know it's 300 something. 360, so I think you're very close. Thank you very much. Very good. So GDP per capita is, you take United States GDP divided by the whole population to get that. Now, what is term B? Term B is your real GDP divided by the number of employed workers. So these are the productive workforce. So we have a name for it. The name for it is average labor productivity. And a lot of time I just use the term, ALP. And that's an important one. And the last term there, term C, is known as the share of population employed. Or sometimes I said something like percentage of population employed. Okay, so I want you to pay attention because these three terms are so important, especially this one, B. So let's look at it for a second. And this is a multiplication, it's not a plus. So you need to know this on the test. So let me ask you a question. Let's just say that if B goes up, meaning that your average labor productivity in the United States suddenly has gone up because of people use more computer technology, all that. So all things being equal, right, then your GDP per capita should also go up, right? Now, what about if suddenly, the percentage of population employed from 40% to 50%? That's a substantial increase right there. So if that goes up, you say that, yeah, this goes up too. This is very important because we asked you this on the test. So I'm giving you a hint now. I hope you get it. That if B goes up, for some reason C comes down, what is going to be the answer for A then? What do you think? What do you think? If one goes up, one comes down, then basically you really don't know the answer. It could be up, it could be down, depending on if the increase or offset the decrease. So bear that in mind, and vice versa. So B could be coming down, people becomes less productive, I don't know how, but C goes up, and then we don't know about this. Unless we tell you specifically, the impact on C is greater than the impact on B, then therefore we know for sure this is going to be down. Okay, let's zero in on these two terms here, A and B. Okay, let's see what we want to talk about. Oh yeah, okay. So let me ask you a question. See if you're good at in deduction in math. Now, you know that in the productive workforce, it's going to be a subset. In math we use this. This means a subset. It's not a C, it's like a C, flattened C. So if N is a subset of the population, and sure, because, this is 40%, this has to be less than that because we got babies. Remember, we got people who are less than 16 years old, and we got retirees who are right here, so that's a subset. So let me ask you this, if N is a subset of population, or you could say if N is less than pop, the same thing. So what do you think? Should this be greater than or should this be less than sign? It's a question I'm asking you.
Less than.
So before you answer that, notice that Y and Y are the same, right? But if population is going to be greater, than N, so this number is going to be?
Greater.
The whole thing. So what do you think is a correct answer there? Just tell me. Should this be less than or greater than? Huh?
It's less than.
It should be less than, right? Now, there's another hint. It should be less than because, see, this is the same number. It's like 5. Okay, well, let's do a number. How about that? Let's do a number here. How about 20? Okay, 20. And this is a 10. This is only a 20. So what is that? This is 10. This is half. Ooh, definitely. Correct? See it? So now, even if you don't know this stuff, you say, oh yeah, what's the deal, you know? So that will be your GDP per capita. So that's always going to be less than your average labor productivity. Well, let's come back to this. Let's just say that this number is whatever, and you know that this is a percentage. And let's say 50. Or it could be 80% or 75%. Now, you know that if you multiply a number by 50%, this number is going to be smaller than that number. Make sense? Yeah. Now you see. Okay, we say all that to show you this diagram. Here it is. So we expect the real GDP per worker, which is your term B or your average labor productivity, to be higher than your real GDP per person because, hey, this right here you divide by all the population. You're spreading out. Too thin, maybe, but over here you're not. That's your GDP. You spread it out among all the productive workers, people who got jobs, people who got paid. So which one do we care? In general, for countries comparison, we look at this because this one is easier to calculate. This one is not so easy because, but yet that's the one that would affect the second one, which is your productivity up here. In general, we call it productivity or average labor productivity, would affect your economic growth or your so-called GDP per capita. So that's a good topic to look at. If you look at share of population employed, oh boy, that looks like about 42% right there. And it makes sense because this is not your, did we look at, remember not long ago we calculated this labor force participation rate? What was it in the neighborhood? Oh, come on. Roughly around 60, right? Because we calculated one time in class, yeah. So that's a labor force participation rate. Remember, we're getting it from people who are over 16 years old. But here we're not. Here we're looking at the whole population, how many people are actually working. So this is including babies, retirees, people who are up to, all the way up to 16 years. So no wonder the percentage is only about 40, not very high. Next, we're gonna ask this question. So what determines a nation's economic growth rate? In the long run, increase in output per person, which is your GDP per capita, term A, happened because of higher in average labor productivity. So again, you know, coming back to the same story, B goes up, A goes up too. So let's look at one example. How many of you have watched I Love Lucy sometime? Okay. So I don't know if you remember that particular episode where Lucy and Arthur, they were like working on the assembly line. We have a picture here actually. Let's look at it. See what it looked like. Oh yeah, okay, page 135. So Lucy and Arthur are on the assembly line. So, and they wrap a box of chocolate candies. And Lucy is considered a novice, not so experienced, so she can wrap 100 candies in an hour. Do you think that's fast? Not really. You could do better, right? Okay. Well, we don't know. We just think it's slow because of the episode we watched. You know, she ended up walloping all the candies into her mouth so she could catch up because the assembly line kept moving. Okay, now, we say it's 4,000 per week. So look at this number carefully with me. I'm gonna ask you a question. Okay, at this point, please put away your cell phone. I really appreciate it. So now, how do you get 4,000 a week? Don't know? Okay, I'll ask you a question slowly until you get the answer. If you think that's a little bit better. How many hours do you work, say, a week?
Probably about 40.
40? Okay, how many hours per day? 5 days a week?
8.
About 8. 5 times 8 is 40. Okay, that's how you get it. So in other words, we are assuming that it's 40 hours per week of work for Lucy. So then how do we get 4,000? Because we take 40 times 100. So everybody understand that number, how we got that 4,000 a week? Okay, good. All right. Now, Ethel is considered a little bit more experienced because she had some kind of training. She can rep 300 candies per hour. Whoa, 3 times better than Lucy. How about that? Okay, again, how do we get that 12,000 right there?
300 times 40.
300 candies multiplied by 40 hours per week. Okay, so we got 2 calculations, remember. The first one is how many candies per hour. That is a rate, R-A-T-E. How fast are you? The other one is in terms of per week, in terms of the candies also. So, okay, the next thing is we want to calculate term B over there, which is your average labor productivity per week. Now, we only got 2 ladies, that's it. These are the whole economy right there. So then what we do is take 1,600. How do we get 1,600? We get 16,000, excuse me. We take 12,000 plus 4,000. That's how we get 16,000 divided by 2, so you get 8,000 per week. Or 16,000 divided by 80 hours. How do we get 80 hours?
Yeah, the 40 hours.
Because we got 2 workers multiplied by 40 hours. Very good. Okay, then you get the average labor productivity, which is only 200 candies per hour. So with that, we have some idea who's doing better than average. This is average. Who's below the average? In this case, Lucy. Okay, so that's it. So remember that 200 candies per hour, because we're going to come back to this number. So let's just say the boss look at it and say, oh, yuck. No good, no good. So we're going to improve situation, and the boss is going to buy a candy wrapping machines. Well, obviously there must be such a thing, you know. And guess who the boss should, assuming that the boss can only give it to one person, one of the 2 workers, which one do you think should get it? Or should the boss give to?
Lucy?
Sorry?
Lucy.
Lucy, yeah, why?
Because Ethel's
gonna do good regardless.
Right, because she's slow, so, you know, if anything else, if you need help, she's the one that, assuming you're not gonna fire her, then she should be the one who get help with the machine. Physical capital, that's talking about a machine. It could be a tractor, it could be a copier, or it could be any machine that you use. Computer, your laptop, your mini pad, or what have you. So worker productivity depends not only on their skills or human capital, but also on the tools that they have to work with. If you ask a man to go out there and plow the field with his hand, it's going to take forever. If you give him a shovel or hoe, okay, that's a little bit better. But why not just give him a tractor? Because we got such a thing called tractor now in the modern technology. Then it's a lot faster. So these are what we call physical capital to help with your productivity. Well, it's just like, you know, I mean, if you were to handwrite 10 pages of your paper, it's going to take forever, especially those of you who have very bad handwriting. But hey, we got word processor, right? You could do that. And even better than typewriter, because if you have a typewriter, that's going to take forever too, if you don't know how to use one. Okay, there it is. Candy company buy a candy wrapping machine operated by 1 worker. They're going to give it to Lucy. And look at Lucy's productivity now. How much? Untrained workers use the machine can wrap 500 candy. Whoa. So instead of 100 candy per hour, now she could do 5 times higher. Look at that. So this is a different set of number now, at least for Lucy. The Ethel's number stays the same. So we got 40 hours multiplied by 500 because now her productivity is being boosted now. Okay, so now it's 20,000. Everybody understand the number? So this number stays the same for Ethel's. Okay? So finally, the total output, again, take that 20K plus 12K, you got 32K candies per week. Again, do the same. You could divide it by 80 hours and then you get 16,000 candy per week, or 32,000, same thing, divided by total sum of the two ladies' hours per week. And then it's simplified to 400 candies per hour. Is this better than before? What was the number I told you before? 200. So this has double. The average productivity is double than it was without a machine. You might say, what's the point? Hey, that's very straightforward. We have a point to make, okay, which is a very important concept in economics. I'm going to give it to you. See the 5 stars? This is when you want to write it down or find it in your book. Is it in your book somewhere? Let's see who can find it. So tell me if you find it in your book. Just tell me.
Page 138.
138? Okay. Thank you. Diminishing returns to capital. Anybody want to read it? To show off that you have book and you brought it today? Go ahead. Yep, go ahead.
If the amount of labor and other inputs employed is held constant, then the greater the amount of capital already in use, the less an additional unit of capital adds to production.
Okay, so what this is saying is that if let's just say that you have 2 ladies, the amount of labor you use are the same. And then the amount of capital you use is the same. That is one machine. So far, we only talk about one candy wrapping machine. And if you keep adding more machine to it, is this going to help at all?
Yeah.
Some of you might say yes, but then there is such a thing called diminishing returns to capital. There is an optimal point in which if you hire too many machines, then it actually is crowding out the productivity. Okay, so the point, this is also the definition, by the way, everybody is in your book, page 138. Okay, so I'm gonna move back to this number here. So let's take a look at this, what I just asked you, the same question. So look at all the columns here. Okay, so over here, column 1, you have 0 machine, 1, 2, 3. Okay, this is talking about the number of machines that you use. So this is here talking about the first scenario we look at without machine. Lucy was doing everything by hand, so 16,000 per week, and then 32,000 per week of candy. It has double. And look at the next 2. So what the next 2 is saying, if you have 2 machines instead of 1, you add 1 more machine, how is it going to improve with the productivity? Okay, 40,000. Improve by 8,000. And then what if you add 1 more machine? What's happening here? Nothing. 0. So the total work hours is the same for the 2 ladies, and then this is where you, again, you take this number divided by that. We calculated the first case scenario, we got 200. Second case with 1 machine, we got 400. We have not done the third and the fourth case, but here is a summary of what would happen if we do. So look at this, 500, because how do you get 500? You get 40,000 divided by 80. You could use your calculator, so you got 500. The last one is also 500. So if you look at it, you say, yuck. Yuck what? What am I talking about here? So if you're a boss, you're a producer of this candy company, you look at it, you say, how many do you think I should hire? Not the labor. Labor is fixed in this case, 2 ladies. So how many machines should I hire? Is it going to be 0? Is it going to be 1? Is it
2.
going to be 2? Is it going to be 3?
2.
Very good, 2. Why is that? Okay, why? Yeah, please, go ahead.
Because if 2 and 3 is the same, then you ordering the third one would just basically take up space because the second one is doing the same thing as the third machine.
Yeah,
Same
this
result
one is
for everything.
definitely you wouldn't use it because your marginal productivity is 0. But over here, if you look at your marginal productivity from 200 to 400 is 200 days. Your marginal productivity moving from 1 machine to 2 machines is only 100. So this is the one that's most worth it. You stop at one machine, not two. Yeah. Well, because I just said, I should have corrected you earlier. Because you see, between 2 and 3 is the same, so you're not gonna use 3. But with 2, you're not doing better. Because here, what is marginal productivity? I probably should define it. So this is how you calculate the productivity. 1 is total productivity, 1 minus total productivity is 0. The marginal productivity of the second unit would be TP2 minus TP1. Okay, so let's put into the formula here. So your marginal productivity of first unit will be total productivity. We could use this one here, okay? Because it's the same. So 400 minus 200, you have 200 here. And then the next one basically says 500 minus 400. So you got 100. Next one we don't have to look at because we know we got 0, right? 500 minus 500. So this is better. So your marginal productivity is maximized at this point, which is one machine. So, but then the concept that you described was correct. You say it got crowded, or it got the machine is in the way. And one of the important concepts of this diminishing returns is because something we call a congestion factor. If you're taking microeconomics with me, you understand what this means. It's like, for example, if you have a plot of land, let's just say 5 acres, which is not very big. You put in one farmer to work. And one machine. Machine doesn't look that way, excuse me. Legs, it's got wheel. This is a machine. And then if you keep clouding in more labor or more tractor in this case, okay, and the machine is the tractor. Oh, and this is only 5 acres. Now you cloud in like, whoa, you know, and pretty soon, hey, the productivity is going to go down if you keep adding more and more. So then the question was asked, where is the optimal number of machine? So in this case, it's 1. Okay, so the point we want to make here, for a given number of workers, adding capital will generally increase output. Yes, we know it's going up, but and we know the average is going up as well, but the more capital that's already in place, the smaller. That's key to it. The benefits are adding extra capital. So this is saying the same thing. Okay, so the degree to which productivity can be increased by keep adding the stock of capital is limited. There's a constraint. Because if you keep increasing, it tends to increase the output, yes, and average labor productivity, but what we want to look at the marginal concept instead of the average. So if you take microeconomics with me, you would also understand that concept a little bit better. Okay, so look at this. On your vertical axis and x-axis, vertical axis, you got real GDP per worker, which is your term B over there, the average labor productivity. And over here is something different. You have never seen this before, have you? This is real capital per worker. It's talking about real capital, not real GDP, but the amount of capital you put in. So you look at the whole bunch of countries here, and these countries that are clustered around here at the bottoms are developing or emerging economies. And these guys up here are the advanced economies. And you see a pattern here, because if you draw a line like this, everybody that cluster around that line could explain the theory that if you keep adding, giving workers more capital than real GDP per worker, you improve the productivity of the workers. It seems like it is true with this evidence that you've seen with developing countries, but not so much with industrialized countries. So if you look at specifically Germany versus US, US is kind of like in the right range or right neighborhood. But look at Germany and even Japan. What happened? as you increase more capital, giving the workers more capital, the real GDP per workers actually move more to the right. So in other words, it doesn't seem to explain advanced countries like, well, even Australia is kind of close, Japan and Germany. Have you ever wondered why? Well, these two countries are the ones that produce a lot of technological stuff, Japan, Germany. So what this is saying is that it may not be true. And this is evidence that, especially in advanced countries, that they have already experienced the so-called diminishing returns to capital. Don't work with those people. But with most developing countries, that is true. Then it comes back to the question of what exactly, and by the way, if you want to do a topic on this, this is a great topic. There's a lot of things that you could explore here. So what explains economic growth or GDP per capita? So it could be explained by more productivity. So B explains A. Well, that explains to you. But that one you can't do much. But this one you can do a lot. Like for example, you might say, why is that people want to come to US, migrate to US to work here? People keep saying, oh yeah, the workforce here is more productive. So what makes economic growth, point A goes up? So we're trying to explain that now. Oh yeah, some countries have natural resources, like South Africa has diamond, has gold. Well, not every country is endowed with natural resources. Look at small countries like Switzerland and Singapore, Hong Kong. It's a small island, so what do they do? Now in Singapore, I happen to be working there for 9 years, so I could tell you stories about this little island right here. They don't have enough land, but they have a lot of money because every year they experience surpluses in their budget. In fact, the population household savings is about 40%. That is like, whoa. In the US, it's only about 2%. Okay, so what they do is they buy land, they reclaim land. So they make their countries bigger. What they do is they buy sand and they fill the sand into the sea, dump them into the sea. And today they build hotel, high rises out of this land that they fill with sand. You see how people could get so creative, and because they got money. Yeah, if you don't have it, you could trade. You could reclaim the land as long as you don't expand it all the way to Malaysia or Indonesia. There's a limit as to how much you could expand. Technology probably explained the most. Since 1995, the internet has became commercialized. So you heard about ICT. How many of you heard about this acronym? ICT stands for Information, Communication, Technology. So, I mean, nowadays, if you have machine, right, or if you have technology, even tracking devices with the tracking companies, tracking devices, excuse me. So there's a lot of communication, transportation, medicine fields are more advanced today because of these electronics and computer, including GPS, that makes you a lot faster, more efficient now. I still have some minutes, so let me finish it. Okay, so we look at the US productivity about right after the World War II, we say 2.8%. And then it slowed down during the first and second oil shock, 1.4. And then after 1995, very important period because internet became commercialized. So then 3% after that. So then we try to explain why there was a slowdown. And a lot of this growth is because of the introduction of, here it is, the ICT, information, communication technology. And there are other factors as well, like entrepreneurship and management. This country's had a lot of people like that. You got, what's the name of that lady? Oprah Winfrey. You got Henry Ford, you got Bill Gates, you got Steve Jobs. I think he died, right? Didn't he? I think he died, yeah. I don't think Michael Jackson would fit into these categories, yeah. Different a little bit different. This is talking about entrepreneur. So, yeah, this country is U.S. in particular is encouraging entrepreneurship. But there are countries that don't. For example, if you look at China in the Song Dynasty, you know, they produced all this stuff like paper, water wheels, gunpowder, and compasses. Wow, we weren't sure about that one. That's why I put a question mark there. Yeah, they were going very well, but then, you know, they're not forging forward because even though you got a lot of scientific advances, all that, but the government do not give them property right. A lot of time, you know, that was restricted by the government political, the political situation in the government regime that will not encourage entrepreneurship. I think they value scholarship much more than entrepreneurship. So the emperor can seize your property anytime without me. That's scary. Okay, so the main point here is please read the rest because I'm not going back to you. I would look at your textbook now very quickly. All these factors you should know. And then it would also talk about communisms like countries like Cuba and Russia. Why? Because you don't have political stability, so therefore economic growth is becoming more stagnant. So I probably will not come back and visit this because we only have a few slides left. But I will encourage you to read this. Some of these are going to be on the test. But okay, page maybe 1 or 2 questions on that.
What page?
Beginning with page 145 all the way to the end. Because a lot of this, there is no analysis really. It's very straightforward. If you read it, you understand it. Very good. I'll see you Monday at BA 220. Have a great week.